Welcome everyone. So today we're going to be doing our unit circle construction, and as I've mentioned, you need a piece of construction paper, a ruler, a protractor, and a compass, and this will represent really our primary study guide when looking at the behavior of all 6 trig functions which we defined for the first time on the previous notes worksheet. So sine, cosine, tangent, cosecant, secant, and cotangent. All those functions now we're going to look at in a very dynamic way as we construct our unit circle. So be ready with it here. I guess the first order of business is to just have your construction paper out in front, kind of elongated horizontally for me. That's how my board is, and I think that's probably the best way to do this. And then so I guess in the upper left-hand corner, if you get an opportunity there, it doesn't have to be too large, but let's just kind of write it as the unit circle. And remember, actually, the equation for the unit circle, x squared plus y squared equals 1. Center definitely at the origin. And the radius exactly 1 unit. And again, what makes the unit circle so visually powerful is the fact that the angle in radians is the same as the number of units moving around the unit circle. And so if you can picture those angles that we should be able to do, all those pi over 6s, all those pi over 4s, all those pi over 3s, all those pi over 2s, if you can picture them and what that angle would look like, then you can see yourself basically on the unit circle. You know exactly where we are in the unit circle. And if you do, then you have a shot at these. So let's give it a try. I'm going to try to do this verbally here, and I'm going to try to draw it out as well. Yours, by the way, will look 1,000 times better than mine, I'm sure. But I'll see what I can do for you up here, and let's go through the process step by step. Okay, so here's what I guess I'll ask you to do initially is just try to find the basic center of your paper there. I'm going to do the same as best as I can. So for me, again, center's roughly there. About the center of your paper if you can get an opportunity. Okay, and then just put a little point there, just like that. And then here's how we're going to start it out, everybody. We're going to do a 10-inch horizontal line segment through that point, and that point needs to be in the absolute middle of the 10-inch line segment. So what you're going to do is line your ruler up 5 inches on each side of that point. And so I'm going to sketch mine up here as best as possible. And give me a minute. It should look something like this, give or take. So again, that would be a 10-inch line segment with your center point being really right at the 5-inch mark. And so yours is now 10 inches long. Perfect, should be nice and symmetrical there. Now what you're going to do for me now is actually just mark off every 1/2 inch on your 10-inch line segment. Okay, so mark off every 1/2 inch starting at the left end point. So what I would do is just nice and light like that, put a little point right there, and then every 1/2 inch all the way across. I'm going to try to do the same up here with mine. I have to do it a little differently, but I'll try to manage. Every 1/2 inch, if you would, all the way across. So I'm probably going to be a little slower than you. It's a little harder up here for me to do it. Okay, so every 1/2 inch, please, if you would. Just make a little mark. And I'll finish up just a sec. And then end it over there. So something like that. Actually, that could be, yeah, it's not bad, not bad. Now, everyone, find that center point, if you would, and just very lightly put a little 0 there. So just a little 0 right there at the center point. I hope that's my center point. Let me count here. Okay, that's mine. And then what you're going to do very simply is each one of those tick marks is going to be a 1/10 of a unit. So what you're going to do is kind of consider this the horizontal number line, just very lightly, guys, so it doesn't take up too much room and doesn't overwhelm your paper because you're going to be doing a lot with this. But again, just very lightly, 0.1, 0.2, 0.3, 0.4, etc. And if you did everything correctly, that should come out right to 1 unit right there. And then, again, repeat the process going to the left. So negative 0.1, etc. And if you did it correctly, that should be out at negative 1 right there. Okay, so you have a horizontal number line going from negative 1 to positive 1 right there. Okay, looks good. Now, everyone, next step, grab that protractor, and what I need you to do is line it up exactly on the 0. Put the protractor right there, everyone, and mark off exactly 90 degrees, please. Exactly 90 degrees. And what we're going to do now is draw the vertical number line, really the y-axis, and it's going to look identical to the x-axis. So again, you put your protractor in, marked off 90 degrees very lightly. Now, guys, you're going to do the same thing. So you're going to make a 10-inch line segment, and the 0, of course, now going vertically, that 0 is going to be exactly at the 5-inch mark. So let's be very clear on that. The 0 is going to be exactly at the 5-inch mark. So let's see if I left myself enough room. I did. And so a 10-inch line segment right through that. So it's going to be perpendicular. It's going to look something like this, give or take. Again, yours is going to look better. It's a little harder for me to do mine up on the board there. Should look something like that, though. 10-inch line segment with the 5-inch mark being right at the center. And then what you're going to do, of course, just like last time, you're going to mark off every half-inch, please, starting at the top and working your way all the way down. So take a moment if you would. This one's really hard for me, but I'll see if I can make it work. Okay, good. All right, so we've got our marks, everybody, going upward, of course, positive. Each half-inch is a 1/10 of a unit. So again, very lightly, guys, very lightly. Not too cumbersome there. 0.1, 0.2, 0.3, 0.4, etc., etc. See if you can get yourself all the way up to positive 1 right up there. So this should be 1 unit right up there. And then working our way down, everyone. Again, not too dark and deep because there's going to be so much you're going to be writing in here as we go through. All the way down to negative 1. Okay, so this is the moment of truth, everyone. When you have that, you're good to go. Again, always feel free to pause the video if I'm going too fast for you, but it should have that on your construction paper at this point. Now here's really the only time you need your compass, and make it a good one. Make it count. So basically what you're going to do is put your compass point right on the origin. You're going to put the pencil right on the initial point here at 1, 0, and you're going to draw yourself, hopefully, a delightful looking circle, really going through each of those 4 1 values, the 1s and negative 1s, and we'll see if you can draw as good a circle as possible. Erase, do what you need to do, just go slow, relax with it. This is where I'm going to just try to do it freehand. I don't have a compass handy, so it's going to be ugly up here, so avert your eyes if you need to. But basically, I need us to go ahead and start drawing our circle all the way through. So, something like that. Ooh, that wasn't too bad, at least a good start for me. But again, you're using your compass all the way through. Should hit the 1s and the negative 1s. So this is so tough to do up on the board here, but I'm going to do it. I'm going to work through as best as I can. I'll take a step back. It could have been quite a bit better, but again, yours is going to look great. Okay, good. So the good news is if you have a circle handy just like that, or quite a bit better, I'm sure, There's only one more step to do. We're going to start to include what I would call our special t-values. And so those are going to be everybody, our pi over 6s, our pi over 4s, our pi over 3s, our pi over 2s, etc., etc. So here's where we get the protractor, and please try to be as precise as you possibly can here. The more precise you are, the more you're going to see these values unfold. But what I need everyone to do is put the protractor right on the origin again. And here's what you're going to do. Up in the first quadrant, you need to mark off 30 degrees, 45 degrees, and 60 degrees. Now, again, I don't have my protractor handy, so I'm really totally just estimating here. So don't go by mine. You're going to just mark off 30 degrees, 45 degrees, and 60 degrees. And when you do that, you are then going to draw 3 diameters going through the first and third quadrants. So 3 diameters should look something like this. So right through that 30-degree mark, and again, make it perfect there. And then right through the 45-degree mark, make it perfect. And then right through that 60-degree mark, as perfect as you can. So something like that there. That looks good. And so we're going to start filling in our t-values. We're going to start filling in our points. And then we're going to start filling in our values. Sine of pi over 6, cosine of pi over 6, etc., etc. Okay, one more time. It's the last part of the construction. That's the good news. And then all the filling in comes in after that. Grab that protractor, if you would, and put it at the origin. And I need you to mark off in the second quadrant, please. 30 degrees, 45 degrees, and 60 degrees. Exactly, guys, has to be absolutely perfect. 30, 45, and 60. And then if you would, you're going to draw 3 more diameters right on through those. Again, I'm not even using my ruler at this point. Basically cutting my losses here. But again, yours is going to look great. Should see a lot of symmetry as we kind of go through this process. So, oof, yikes, ugliness. Oh well, hey, it is what it is, and it's not about mine, it's about yours. So when all is said and done, you're going to have that as your construction. There might be one last thing I ask you to do, but that'll be kind of towards the end. That's what you're going to have to do with your construction at this point. Okay. Now, I think what I want to do here is actually put the points in place first. So remember, t can be any real number as we move around the unit circle, either counterclockwise or clockwise. What we're going to do is basically go through what's called our primary rotation. Once around the unit circle counterclockwise. That's what we're going to do, everybody. Once around counterclockwise. And so what I'm going to do is start at my initial point, and I'm going to stop at these special t-values and talk about really the ordered pairs initially. So before I do that, there's one last thing I need us to write just off to the side here. There are really 3 x's and y values that are going to pop up time and time again as we move around our unit circle. So these are the 3. I'm going to come over just to the left-hand side. And again, I'm not going to do this huge by any means. And on yours, I would just do it nice and light. But you're going to see 1/2. Now, we all know, of course, 1/2 is 0.5, so that's not a big deal. One of the other fractions you're going to see, which you saw in yesterday's notes worksheet, is this square root of 2 over 2. Now, square root of 2 over 2 is about 0.707. So just keep that number in the back of your mind there if you get an opportunity, and you'll see it pop up. Okay, and then there's one other number that you're going to see, and this would be the square root of 3 over 2. And if you took the square root of 3 and divide by 2, it's about 0.866. Now, in some respects, you're going to have to take a little bit of a leap of faith with me in terms of these numbers, where they come from. As we progress through a variety of notes worksheets and a variety of representations for these trig values, I will show you exactly where square root of 2 over 2 comes from and exactly where square root of 3 over 2 comes from, and the 1/2 as well. But for right now, I want you to just keep an eye on those numbers, and I'll show you what pops up as we go through. Okay, everyone. So here's what I'm going to ask. Start right at the initial point if you would. Just a little parenthesis right there. And that, of course, is 1, 0. That's our initial point. That's where we're starting. Okay, good. Now, everyone, I'm going to move around counterclockwise. I'm going to go from here to here, everyone. And if I stop right here, basically this point on the unit circle has an x and a y. I actually know those x and y coordinates. So what we're going to do is fill them in. And I will tell you that each of those will be one of these three numbers here. So start the process visualizing already. Look at the x value, everybody. So the x value, try to match it up to the x-axis. And it's not going to be perfect, especially on mine. But I guess I would ask you, if you look horizontally here and match it up to the x-axis, and here's the x value, it seems to be about right here, does it look like that's 0.5, 0.707, or 0.866? Now, if you did your 30-degree angle perfectly, it should be that 0.866. Even mine, as poorly as I ended up doing mine, I could see that it is that 0.866. So as a matter of fact, everyone, this x value is square root of 3 over 2. So please put that in, root 3 over 2. Now the y value, everybody, is the vertical, of course. So the y value, what I want you to do is try to measure it up as best as possible. Come on over to the y-axis. Now this is where I did not do a good job at all. But if I sort of think about it in terms of those numbers, and you hopefully will see it, you should see that the y coordinate right here is actually the lowest of those three numbers. It should be exactly 1/2 if you did everything correct. So the x value there is root 3 over 2, and the y value is exactly 1/2. Okay. Now let's go to the next one. I'm going to stop right here at my new point. And let's go ahead and put in this next piece right here. And so here we go. X value. Again, everyone, what I would do is grab the ruler and match it up perfectly to the x-axis. Actually, it looks like I did better on the x's than I did on the y's. But see over there, look at those three numbers that you wrote, the 1/2, the root 2 over 2, and the root 3 over 2. Do you see this one right here? It looks really nice. This one is, the x value is root 2 over 2. And you should see that on yours, that your x coordinate should be really right there at about 0.707. Now again, the y value is where I kind of messed up here. But basically, if I kind of come over here and match it up, you should see it on yours that the y value is also square root of 2 over 2. So that's that point right there. So I've got root 2 over 2, comma, root 2 over 2. Okay. We'll be able to go through a little faster after we hit the first quadrant here. Let's stop at the next special t value, and we'll get to those t values in just a sec. But let's get some points in place. Now, everyone, x value, match it up to the x-axis. And again, I did a pretty good job here. Does everyone see on yours? It looks like the x-coordinate is exactly 0.5, so please write that as a 1/2. In this one, at least I did a slightly better job. Look at this one, everyone, up here. Look at that y-coordinate. I'm hoping everybody sees it's really right in that 0.866. It's the square root of 3 over 2. Okay, good. Hey, guys, let's hit the top of the circle. This one, actually, we saw yesterday. So at the top of the circle, my x value is 0, and my y value is 1. Now, everybody, what you're going to start to see is those exact same numbers. As we go through the other quadrants here, we just have to be careful with positives and negatives, but you will see a lot of symmetry here, everyone, so keep an eye on the symmetry. And this will continue as we go all the way through our labeling process. So here's what I'm thinking. This point right here on the unit circle corresponds to a t, and it also has a particular ordered pair that goes with it. And what I would do, everyone, is see this one? I'm going to relate it to this one right here. If you look, everyone, the horizontal is actually the same as it was on the other side. It should be 0.5. The only problem is we went to the left. So it's negative 1/2. So remember, in the second quadrant, x is negative. And take a look at the y values. The vertical piece, everybody, should be exactly where the other one was on the other side. So this one had a y value of root 2 over 2. This one, everyone, sorry, root 3 over 2. And this one has root 3 over 2 as well. Cool. Symmetry, everyone. See it? The one that splits the quadrant right here, now I'm hoping everyone is starting to get a little better with this. So this would be negative root 2 over 2 and root 2 over 2. And again, you can match it up, everyone. My horizontal looks great. So in this case, notice, take a look right there. There's about negative 0.707. It's just my vertical kind of got messed up there. But yours, I'm sure, is fine. Okay, perfect. This one right here, everybody, is negative root 3 over 2, comma, 1/2. Okay, almost halfway around. Saw this one on the previous notes worksheet. If I go halfway around the unit circle, I'm at negative 1, 0. Okay, doing great. Now third quadrant. The only thing we have to be careful of in the third quadrant, of course, is that x is negative and y is negative. If I found my x coordinate, by the way, it would be negative root 3 over 2. As a matter of fact, here it is. Here, go to the x-axis. There's your negative 0.866. The y value is actually negative 1/2. All right. This is one that was on the notes worksheet yesterday. There's negative root 2 over 2, negative root 2 over 2. Down here, everyone, this would be negative 1/2, negative root 3 over 2. And down at the bottom of my unit circle, we'll definitely see this. Down at the bottom, everyone, that's 0, negative 1. Okay, one more quadrant to take care of. Fourth quadrant, everybody. Remember, we talk about this in Trig. Direction matters. So you have to be really careful where things are positive and where things are negative. This one right here would be 1/2 and negative root 3 over 2. Next one, this looks to be root 2 over 2, negative root 2 over 2. And the last one right here, this is looking great. Looks like root 3 over 2 and negative 1/2. You can really hopefully see those as you match up the x's on the x-axis, match up the y's on the y-axis. You can really see those numbers unfold from the way I gave you my decimal approximations, especially with these two. Okay, again, just takes time to fill in. One big thing taken care of, the points. Now, everyone, we have to start talking t values as I move once around counterclockwise. So that is our next step. So let's refocus and get that taken care of. Everybody, let's start and stop right there. And if I do that, t is 0. I haven't moved anywhere, so t is 0. It would be 0 radians in terms of the angle measurement. There it is. And of course, it would be 0 units around our unit circle. Now, everyone, here's the key. This, to me, is even more important than the points. Can you get the t values that correspond at each of these spots? So if I've gone from here to here, from there right to there, how far have I moved around the unit circle? Well, let's make our connection. T represents two things. It represents how far we've moved around our unit circle, and it represents the central angle in radians. Well, remember, everybody, I had you draw this angle as exactly 30 degrees. So this is 30 degrees right in here, and you should know at this point that 30 degrees is exactly pi over 6 radians. And so if this is pi over 6 radians right in there, which is it is, then this is pi over 6 units on the circle. So t, everybody, right there is pi over 6. So when I ask you for the sign of pi over 6, which I definitely will, you need to be able to visualize where you are and then start to think about x's and y's. Okay, next one. What's the t value coming from here to here? So from there right to there. Remember, I had you construct a 45-degree angle, and 45 degrees is pi over 4. So this is exactly pi over 4 units. Perfect. Next one, everybody. Think about this. I had you construct a 60-degree angle, and 60 degrees is pi over 3. So this would be t is pi over 3 at that spot. Again, if you need to find some room on your unit circle, do what's best for you. Don't copy necessarily what's working for me on the board here. Okay, if I've gone a quarter of the way around, everybody, that would be a 90-degree angle. 90 degrees, of course, is pi over 2. Let's see if I can get it up there. Nope. So I have to come right here. So that's pi over 2, everyone, at the top. Now, the beautiful thing is, as we start to move into the second and third and fourth quadrants, is all the symmetry. So look at the position, everybody, of the pi over 6. That's the one closer to the x-axis. The pi over 4 is the one that splits the quadrant in half. It's in between the other two. And the pi over 3 is the one closer to the y-axis. So think of that. 6 is closer to x, 4 in the middle, 3 closer to the y-axis. Well, everyone, basically what you're going to see is that exact same pattern hold for the other 3 quadrants. Okay, so let's go to the next one. And by the way, the next one, if I asked you for that angle, you would say that that's 90 degrees, plus actually that happens to be another 30 degrees, so this is 120. 120, as we do know in radians, is 2/60s, or 2 pi over 3. And so this is t equals 2 pi over 3. And look at the pi over 3 here, everyone. Here's 2 pi over 3 right next to it in the second quadrant. Excellent. Let's keep it going. Pi over 4s are in the middle, everyone. This happens to be 135 degrees, which is 3 pi over 4. So we had 1 pi over 4, now 3 pi over 4. Excellent. Told you the pi over 6s are the ones closer to the x-axis. And so in this case, the pi over 6 here, this would be 150 degrees, by the way, which is 5 pi over 6. Again, you don't have to do it exactly the way I'm doing it. Just find a way to write that in there for what works with you. Okay. Next one, halfway around, we saw this one. That would be pi units. So halfway around the unit circle, you've gone exactly pi units around. Okay, so again, look at the positions of the 4s, the 6s, and the 3s. That continues in the third and fourth quadrant. Think about it. Do you think this will be a pi over 4, a pi over 3, or a pi over 6? And this one right here is 7 pi over 6. It's 210 degrees, 7 pi over 6. Must be able to visualize them. The ones in the middle, everybody, are the pi over 4s. It went 1 pi over 4, 3 pi over 4. This one's 5 pi over 4. And then down below here, at this spot, everybody, this is a pi over 3. It's 240 degrees, which happens to be 4 pi over 3. Okay, so 6s, 4s, and 3s. We're through 3 quadrants at this point in time. We're going to get to down here and then the last quadrant. So if you've gone 3/4 of the way around the unit circle, that would be 270 degrees. And as we all know, 270 degrees is 3 pi over 2. So that's at the bottom. 3 pi over 2 units puts you at the bottom of the unit circle. And in the fourth quadrant, everybody, think about it. Do you feel like this is going to be a 3, 4, or 6? Should be a 3. And as a matter of fact, it's 5 pi over 3. 300 degrees. This one, everybody, is 315 degrees, which happens to be 7 pi over 4. So notice the pattern on the 4s, everybody. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. This one is going to be a pi over 6. It happens to be 330 degrees. I told you this would come up. And that's 11 pi over 6. Now, everyone, if you've gone once all the way around the unit circle, how far have you traveled? Well, the angle measurement, of course, would be 360 degrees. That's without question. We do all know that 360 degrees is exactly 2 pi radians. And so as a result, everybody, if you've gone once around, you've gone exactly 2 pi radians around the unit circle. Or I should say 2 pi units around the unit circle. Now, theoretically, could we keep going? Certainly. There's no end in sight. Could I have done this clockwise? Of course, of course. This is just what's called our primary rotation around, and these are the values that probably come up most prevalently. So those are the ones we're going to focus on. Okay. Really one more huge step, and then we'll see what we want to do at that point. Basically, here's what I'm going to ask us to do at this stage. We have to now figure out what is the sine at each of these t's, what is the cosine at each of these t's, what is the tangent at each of these t's. If we know the primary three, if we know sine, cosine, and tangent, then we definitely have a shot at the others because we can just flip them and get cosecant, secant, and cotangent. So just over the years, I've seen students actually write these values literally on the terminal side. I'm going to do that probably the first and maybe the second time. And then after that, I'm going to have to bail and just do it off to the side. But I would ask you to continue to kind of work through it all the way on these right here. So take a deep breath and let's take the plunge. So here's what I'm going to ask us to do. And I hope you can read it as we go through here. So I'm going to ask us, what is the sign of 0? And if you figured out the sign of 0, well, as soon as you hear sign, think y coordinate. And here I am, everybody. And the y coordinate right there, of course, is 0. Sign of 0 is 0. Input is 0. Output is 0. Now, everyone, the second one, cosine of 0. Again, if t is 0, then I'm right here on my unit circle. And if I'm right here, do I know that x value? Sure. The x value is 1. Excellent. And last but not least, for this one, tangent is 0. So again, just kind of write it in nicely on yours. I think that's the best spot for it when all said and done. Tangent of 0 is y over x. Y over x happens to be, in this case, 0. And that's what it's going to look like all the way through, everybody. Inputs and outputs. I'm going to do one more with you. I'm going to try to do it right in the terminal side like I did here. If I can't, I'll just start moving off to the side. So let's go for it. Here we go. Sine of pi over 6. If you were to type in sine of pi over 6 on the calculator, you would get just some number here. That number comes from this idea, at least. This is our perspective on it. And the sine of pi over 6, everybody, is just the y coordinate at that point. And so the sine of pi over 6, if you were to do it on your calculator, would give you 0.5. So sine of pi over 6 is 1/2. Cosine of pi over 6, as soon as you hear cosine, think about the x value. Cosine of pi over 6, everyone, is square root of 3 over 2. Good. Now, everyone, the tangent value here, you would do y over x. So we saw this once or twice before. You would do 1/2 over the root 3 over 2. Now, I'm just going to end up telling you what happens here when all said and done. If you do the 1/2 over the root 3 over 2, the 2's cancel. And you end up getting the 1 over root 3. Well, again, you rationalize these. So if you were to rationalize 1 over root 3, and you know what, this is not going to work for me, so I'm going to do it off to the side here. So the tangent of pi over 6, you keep doing it in the terminal side there, but tangent of pi over 6 would be 1 over root 3, which turns out to be root 3 over 3. That's tangent of pi over 6. Okay. Now, everyone, I'm going to start to move just a little faster, and pause at any time if you don't catch anything. But I'm going to give you the remaining ones. You put them in. I would just kind of work your way around. Keep rotating your unit circle around as you get the chance. Okay, so here we go. Sine of pi over 4, everybody, is the y value, root 2 over 2. Cosine of pi over 4 is root 2 over 2. Tangent of pi over 4, if you take those and divide them, you end up getting 1. Okay, good. Next one, let's do the pi over 3. Sine of pi over 3, everyone, as you can see, is square root of 3 over 2. Cosine of pi over 3 is 1/2. And tangent of pi over 3, now this, you would get y over x. Same thing, the 2's would actually cancel, and you get root 3 over 1, which of course is just root 3. So tangent of pi over 3 is just root 3. Okay, on to the next. And pi over 2, saw this on the previous notes worksheet. Sine of pi over 2, everyone, is 1. Cosine of pi over 2 is 0. Tangent of pi over 2, if I try it, y over x, no luck, undefined. Okay, so we've got that first quadrant taken care of there. Now again, here is the beauty of it. Now I'm going to let you kind of take over from here, and we'll probably stop at this point, well, in just a few minutes. But you're going to continue working your way around here. There's really, I think I've said my piece in terms of these values here. If you have further questions, of course, please don't hesitate to ask. But you'll notice, of course, that all the sines and cosines and tangents of all the pi over 3's are the same. You just have to be careful of positive versus negative. So if you just did pi over 3 right here, let me just make sure I've got my pen at least. If you've got sine, cosine, and tangent of pi over 3, then you're going to be able to do the sine, cosine, tangent of 2 pi over 3. They're the same numbers. You just have to be careful, of course, because we're in the second quadrant, and x is negative and y is positive. So that's all you have to be careful of. What I would do is just rotate your paper and take about 5 minutes and just kind of finish that up there. Okay. I think I'm going to end the construction at this point in time. What I'm going to ask you to do is not try the homework. I just want you to look at this and kind of see some of the patterns in place. And what we're going to do on the next lesson is just get some practice on this. And I'm going to start asking you all these values. I'm going to ask you, what is the cosine of 7 pi over 6? And you would envision yourself right here, and you would know that the x value is negative 3 over 2. I'm going to show you some hints and some ideas as we go through that particular process. But for right now, just familiarize yourself with these values. The first thing you really have to know to be successful at this is where you are on the unit circle. So if I ask you for the cosine of 7 pi over 4, you're not going to be able to know the cosine of 7 pi over 4 if you don't know where 7 pi over 4 is. So you would have to envision yourself right here on the unit circle. Now you could probably figure out the cosine of 7 pi over 4. So you'll hear me ask the question, where are you on the unit circle? If you can pull that off, you're in good shape. Okay, so again, what I would encourage you to do is just take about 15 minutes tonight and really, really look it over in detail before trying the next lesson, which is just practice on this. Okay, if you have any issues with your construction, please don't hesitate to ask. If you want to check answers, please check with your neighbor, check with me, whatever the case may be. But it kind of defeats the purpose of me just kind of going around and writing stuff in at this point. It's all there for you. Excellent. Well, thanks. And again, look it over before trying some practice stuff, because the practice is really where I'm going to hold you accountable for knowing all these values.